Welcome to our discussion of linear growth, or a fancy way of saying straight lines. Our objectives for this video are to understand linear functions and linear growth, i.e. everything there is to know about straight lines, and then be able to model data with linear functions, kind of come up with a straight line function given some data. All right, what do we mean by linear growth? Well, linear growth just means that the dependent variable is growing linearly in relationship to the independent variable. So every time the independent variable goes up by 1 unit, the dependent goes up or down, because growth could actually be decay, be the negative direction. It changes, let's say, by the same amount. It doesn't have to go up by 1, it doesn't have to go by, even by a whole amount. It can go up by a half each time, or go down by a third, or go up by 6.3. But as long as that increase is consistent, then you get a straight line function, and you get linear growth. Okay, we've already seen proportions, and proportions were defined as the relationship between quantities that vary at the same rate, or things that vary directly with each other. Well, that's a version of a linear function, or linear growth. If you've ever seen direct variation, where they talk about y varies directly with x, or w varies directly with k, those are also versions of linear growth, linear functions. Let's look at an actual example. Jessica's interested in purchasing a new video game that costs $60 if she has a job that pays $7.50 per hour. See that per hour? That's one of those proportions, right? Per thing. So we know that that's a linear idea right there. Find a linear equation for her income and determine the number of hours she must work in order to have enough money to buy the game. So we know that her money is $7.50 per hour, and we can, let M maybe be money is going to equal 7.5x, where x is the number of hours worked, right? If she works 10 hours, she gets $75. Now, that's our first part. That's easy. Now, if we want to figure out how much time she has to work to be able to afford the video game, well, doesn't that mean we just need to know when her money is equal to 60? And then divide both sides by 7.5 to get your answer. Right? Here's some examples, and we can see that 8 gets the money we need. So this is the solution, right? She has to work 8 hours. We've taken a real world thing, we've fit a linear function to it, and we were able to find the answer to the question. If we were to graph it, it would look something like this, and we would see the answer would still be the same, that she needs 8 hours of work to make $60. All right, give this one a try. Pause the video and see if you can get the right answer. Did you get y equals 6.75x and that he needed 32 dozen? Hopefully. Okay, slope. Anytime we're dealing with linear functions or straight lines, we're always dealing with slope, which we normally represent by the letter m. Makes no sense, right? M has nothing to do with slope, but there are actually a few theories as to why it's an m, but nobody knows for sure. Anyhow, who cares, right? Rise over run, that you've probably heard that before, or change in y over change in x. Those are all ways of describing your slope. Pictorially, right, rise over run just tells you how steep or how shallow the line is. Now this formula, some students have it, some people don't. Don't get confused and caught up with the whole y2 minus y1 over x2 minus x1 thing. The bottom line is you pick a point, you pick another point, you find the difference in the y values, the difference in the x values. All you have to make sure is, right, it doesn't matter which one is y1 and which one is y2. All that matters is whatever you let be y2, you have to let the corresponding x be x2, right? So you got to go 2 minus 1 over 2 minus 1. If you go 1 minus 2 over 1 minus 2, it doesn't make a lick of difference. You just have to be consistent, right? So if you switch places with these two numbers, you got to switch places with those two numbers. So you pick a pair, that's going to be your lead pair. You're going to take that y, subtract this y from it. So you're going to take that x, subtract that x from it. If you want to go the other way around, that's fine. You take this y, subtract that y from it, but then you got to take this x and subtract that x from it. Since it doesn't matter which way you do it, my suggestion is let the lead pair be the bigger y so that the top is positive, right? So a big number minus a small number, you get a positive number on the top. And then that way, if you get a negative number on the bottom, you know the whole thing is negative. If you get a positive number on the bottom, you know the whole thing is positive. If the top is negative and then the bottom ends up coming out to be negative, then you got to remember that a negative over negative cancels out and becomes a positive. And that's just places where people make mistakes when they're in a hurry, in a test situation. So the safest way is to just always let your lead pair, right, the first pair that you're going to subtract the other ones from, pick the bigger y. Okay, a linear function is just exactly what we've already seen before. It's y equals mx plus b. It's a straight line, but instead of y equals mx plus b, we're going to call it f of x equals mx plus b, right? A lot of these functions that we're going to be dealing with, they're the same thing that we've seen before, only now we're going to treat them as functions by putting this little function notation in there, and nothing's changed. The only thing that's different now is we're considering it a function, which means it's supposed to represent something in the real world rather than just some arbitrary bunch of algebra. But all the rules are still the same, right? You solve them the same, you figure out the slope the same. If you've dealt with straight lines, you've dealt with linear functions. Okay, assume you have $20,000 in a bank account that you'll use to pay your college tuition. If the cost of your college tuition is $2,500 per semester, use a linear function to find the number of semesters it would take for the account to have a balance of 0, and assume that this bank account does not earn interest, right? So you're basically just figuring out how many $2,500 checks you can write out of an account that has 20 grand in it. And that should be pretty easy, right? It's just going to be 20,000 equals 2,500 x. And when you solve for x, it tells you how many times you can do that. Well, we can kind of just play around with numbers and plug them in and figure out it takes 8. Or we can go straight to the equation and solve it that way, right? We can go straight to the idea of, we know it's a linear function. We know it's 2,500. You know what? I'm going to use a different letter just so we know it doesn't matter. I'm going to say 2,500p for payments, right? P is going to be my number of payments. And how many $2,500 payments can we make with our $20,000? And you go, oh, you just divide both sides by 2,500 and P equals 8, right? If you graphed it with 0 payments, you've got 20 grand, and it just keeps going down and down and down and down and down. Now let me ask you this, guys. In reality, would this function really have the blue line on it? Or would it just be a bunch of red dots? Wouldn't it just be a bunch of red dots? Because you can't make a half of a payment. I mean, you technically can, but in the context of this, we really can't make partial payments. We take away 2,500, then we take away another 2,500. And all of this blue stuff really doesn't make sense in the context of the question. And that happens a lot, actually, with linear functions, is they're only really truly defined at the integer values, because we're talking about something that can only be, you can only have integer values of them, where you're counting things. But we go ahead and connect the dots and make a straight line just so we can deal with a line and a linear function. Okay, intercepts. Hopefully you've seen these before. The x-intercept is just where the graph intersects the x-axis, the horizontal line, and the y-intercept is just where it intersects, right? They kind of sound the same, the y-axis, the vertical line. Slope-intercept form is y equals mx plus b. You should be very familiar with that. And if you didn't know that was called slope-intercept form, who cares? Okay, another example. Assume Jeffrey has an uncle that puts away $10 in a shoebox on the day he's born and adds $5 to the shoebox on his birthday every year. If this trend continues, use the linear equation to find the amount of money in the shoebox on Jeffrey's 18th birthday. Well, We know it's a linear function, so we know it's going to be of the form y equals mx plus b. Where do you think the 10 goes? Well, hopefully you all see the 10 goes in for b, because that's the intercept, right? When x equals 0, i.e. when you're born, because x is going to be, number of years, so when you're at 0 years old, you've just been born, he puts 10 bucks in the shoebox. And then for every year, how much does he add? 5. So 5 is the change. That's the slope. That's how much you put in for m, and that's how much it goes up every year. You can see that by just going, okay, he's got 10 after 1 year, sorry, at the beginning, 15 after 1, then 20, 25. You can see it goes up 5 each year. So we know this has to be our function. If we plug in 18, because you're 18 years old, you can see that you have a whopping $100 in the shoebox when you're done. And then there is the graph. Again, does the blue part make sense? No, not really, right? But we have to kind of put it in there just so the whole thing becomes a linear function. One last skill check, sorry. So Cindy's starting a business, selling t-shirts, blah, blah, blah. Order cost $9, art fee of $12.50 per order, find a linear function, da, 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 da. So go ahead, read this one through, pause the video, see if you can get it correct. Did you figure it out that the artwork setup fee is your initial cost, right? That's your B, that's your y-intercept. That's how much you pay no matter how many shirts you order. And then the total cost is going to be 9 times each shirt plus that initial cost. All right, very good.